Alright, so we're going to start out with Lecture 3 of Unit 2. Lecture 3 is going to focus on the basic atomic structure of atoms. Now, many of the component parts of atoms you should already be familiar with, and so it should be somewhat of a review. There might be a few new terms and ideas that you're not familiar with or that need to be further looked at in this lecture. So here we go. Our essential question for this lecture is, what is the basic anatomy of an atom? And so by the time you're done with reviewing this lecture, looking at your notes, you should be able to label the parts of an atom, be able to know what those basic parts are, their functions, where they're located within the atom, for the quiz that is taken in class. Okay, so first of all, let's take a moment and define what atoms are. What exactly are these things that we call atoms? Atoms are, first of all, very tiny. So they're very small. You can't see them with a light microscope at all, so they're submicroscopic. We have to use models in order to be able to understand maybe how they interact with each other, as we talked about in the first lecture of this unit. We know that atoms, being very small particles, basically all atoms make up elements. So all atoms make up elements. And what we know, and what we'll look at a little bit more later, is that there can be multiple atoms that make up an element. For instance, the element carbon is composed of 3 atoms. And we'll talk more about what that means a little later on. So what are the basic component parts of an atom in the first place? Well, first of all, the atom is composed of 3 subatomic particles: the proton, the neutron, and the electron. The proton and the neutron are located in the atom in a place called the nucleus. And the electrons are found within what are known as energy shells. Oops. Inner shells. Sometimes they're called energy levels as well. Alright, so some specific ideas of what we know about protons is that protons are positively charged particles. Neutrons have no charge, or 0, and electrons are negatively charged particles. Now, electrons, protons, and neutrons are much, much tinier than the atoms themselves. Okay, so let's label the basic parts of an atom. Okay, in the center here of an atom, this is known as the nucleus. And what we just got done talking about is the nucleus is made up of the protons and the neutrons. And so we can use this to identify a proton, and the other one here we'll label as a neutron. Alright, and outside around the nucleus is going to be the electrons. Here is an electron. These electrons are found within energy shells. Or levels. Alright. What else do we want to know? Oh yes, the outer electrons, the most outer electrons in the outer shells of an atom are referred to as valence electrons. Okay, valence electrons. Alright, so these are the basic parts of any atom. The nucleus, which is composed of protons and neutrons, the energy shells, which surround the nucleus, and that is where the location of the electrons are, and then the valence electrons are in the outermost energy shells of an atom. Okay, so make sure you spend some time learning these different parts if you don't already know them. Alright, so now what we're going to do is we're going to get more particular about electrons, protons, and neutrons. And we're going to fill out this table. Okay. Now we have already stated that the charge on a neutron is 0. There is no charge. It's neutral. And so we can write, actually let me make this smaller here. So it's 0 charge because it is electronically neutral. Whereas a proton is positively charged. An electron is negatively charged. Okay, the relative mass, basically we use a special unit called AMU. AMU stands for atomic, A for atomic mass unit. And so a neutron is 1 AMU, or 1 atomic mass unit. A proton is roughly the same size as a neutron, so it also has 1 AMU. Where a electron is much, much smaller than a proton. An electron is about 5.486 times 10 to the minus 4 AMUs. So essentially we almost say that an electron is 0 AMUs. It is so dang small. An electron is, you might want to record this, is about 2,000 times smaller than a proton. So again, an electron is about 2,000 times smaller than a proton. Very, very small these electrons are. Whereas neutrons and protons are roughly the same size. Okay, where do we find neutrons? Well, as we discussed before, they're found in the nucleus of atoms. Protons are also found in the nucleus of atoms. And electrons, again, are found in energy shells. Alright, so there's some characteristics of a neutron, proton, and electron. By the way, let's talk about how we symbolize a neutron. We normally just put a N for neutron, a proton, a P with a positive sign to let us know that it's positive, and an electron, an E with a minus sign to know that it is negatively charged. Alright, so what is the atomic number of an atom? The atomic number of an atom is the number of protons an atom has. The number of protons an atom has. And if you remember, when we looked at lecture 2 of this unit, we talked about the atomic number and how to find it on the periodic table. So if you get out a periodic table, if you want to pause this and take a look at it, look at and find the element carbon. And you will notice that carbon has an atomic number of 6. Which means that carbon has 6 protons. If you look at the periodic table and you find oxygen, what is the atomic number of oxygen? That's right, it's 8. So oxygen has 8 protons. Okay, let's look at the element, let's find sodium, which is Na on the periodic table. How many protons does it have? It should have 11 protons because it has an atomic number of 11. Alright, so make sure you understand what the atomic number of an atom is and be able to identify the number of protons that an atom actually has. Okay, the next question is, what subatomic particle, electron, proton, or neutron, is used to identify an atom? All atoms use the proton number to identify an atom. This is really important to understand. It's because the number of neutrons for an atom can change, as well as the number of electrons. But the proton number never changes. So what makes carbon, the element carbon, is because all atoms of carbon has 6 protons. What makes oxygen oxygen is its atomic number, the fact that it has 8 protons. If the number of protons changes for oxygen, then it would have changed the whole identity of oxygen. So again, the proton number identifies the actual atom and what element we're looking at. So make sure that you remember that. That's very important. Like this, we're going to put a star by that. It's so important. Okay, so now what we're going to do is look at a concept that can be kind of difficult for some students, and that is isotopes. So what we're going to do is define what the term isotope is, you should become very familiar with basically the terminology of an isotope. But basically, we're going to say that two or more atoms that have the same protons number but have different number of neutrons. Alright, so again, an isotope is when you're comparing two or more atoms that have the same number of protons, but they differ in their number of neutrons. This is an important definition. Please make sure you know this definition. Okay, please make sure that you are very familiar with this definition for the quiz and for the test. Okay, so let's take a look at these two models. So remember we talked about in the first lecture that we would often use models to represent how matter behaves. And so in this case we're going to look at two atoms, and if you look closely, these two atoms are not exactly the same. They do have the same number of protons, however. And the protons in this case is represented by the black circles in the nucleus. Alright, for each one of these atoms. So each atom has how many protons? If you said 3, you would be correct. So what atom on the periodic table has an atomic number of 3 or is made up of 3 protons? Take a look at your periodic table. Alright, yes, that would be lithium. Li. Now, because both these atoms have the same number of protons, both these atoms must be lithium atoms and make up the element lithium. But what they are differ in is the number of neutrons. And the neutrons are going to be the white ones oops, misspelled that. So the neutrons are in white for each one. How many neutrons does this particular element or atom of lithium have? That's right, 3. So we're going to say that it has proton number 3 and neutron number of 3. Our other atom over there has proton number of 3, which makes it a lithium atom, and it has 4 neutrons. So notice these two atoms must be isotopes of each other because they have the same number of protons, but they differ in their number of neutrons. And so that fits our definition of what an isotope is. Again, these two atoms have the same number of protons, both of them have 3, but they differ in their number of neutrons. So therefore, they are not the same atom, however, they are from the same element, lithium, and they are known as isotopes. Okay, so let's look a little bit closer at some isotopes. What are the structural differences between atoms of the same element? So again, we can look back at our definition of what an isotope is. So the differences in their structure is simply between the number of neutrons. Okay. So any atom that is from the same element will differ in their number of neutrons. But what is the same? Well, the same is the number of protons. Is the same. All right. Next question. Do isotopes of the same element differ in their physical and chemical properties? Well, the answer is yes and no. Yes, for physical properties, isotopes will have different physical properties, but no for chemical. So isotopes have the same chemical properties, but they differ in their physical properties. Okay, now let's see if we can symbolize or learn how to write isotopes. Okay, so let's look at the element carbon. Carbon is made up of 3 different isotopes. Their isotopes of carbon all have, of course, the same number of protons, which in this case, if you look at the periodic table for carbon, it has an atomic number of 6. Therefore, all isotopes of carbon have 6 protons. So we have 3 isotopes, and we're going to put our 3 symbols for carbon. On the bottom, we're going to put the number of protons, like that. The 6 represents the atomic number, or the number of protons. Up in the top left-hand corner, we are going to put the atomic mass for each one of these isotopes. For carbon, we can have an atomic mass of 12, 13, or 14. Right? So, what is the atomic mass telling us? Well, it tells us the number of protons and the number of neutrons. So, total number of protons and neutrons. Okay, is this number right up here. And this is also known as the mass number. Whereas this is known as the atomic number. Alright, so with carbon-14, it has a total of 14 protons and neutrons added together. Well, if we know that carbon has 6 protons already, then 6 minus 14 gives us the number of neutrons, and that would be 8 neutrons. So we know that carbon-14 has 8 neutrons and 6 protons. What about carbon-13? Well, carbon-13 has a total number of 13 protons and neutrons combined together. So if we subtract 6 from 13, it will tell us the number of neutrons it has. So let's write this down. We know that it has 6 protons, and it must have 7 neutrons. Okay, let's do that for carbon-12. Carbon-12, of course, has 6 protons, and the number of neutrons, well, 12 minus 6 is 6. So it has 6 neutrons. We can also do the same for carbon-14 over here. Protons, actually, let me erase some of this. So protons is 6, of course, but the number of neutrons is 8. And that would be 14 minus 6. So notice that all these carbon atoms have the same number of protons, which is 6, but they have different number of neutrons, 6, 7, and 8. Therefore, all 3 of these atoms of carbon are known as isotopes of carbon. And all 3 combine together to make the element carbon. So what we normally will do then is we will always write the symbol. So let's say X represents any element. And then we'll put the atomic number at the bottom. And up at the top left corner will be the mass number. Always. Alright? And so those are different ways in which we can symbolize isotopes. Okay, now I'm going to erase this. And in your notes, try to find some more room for this. But we're going to look at writing some elements, isotopes, in some different other ways. Okay, so let's take a look at oxygen. So oxygen has how many protons? 8. So we'd have to put 8 down here. And there are 2 isotopes of oxygen. We'll use oxygen 16. So it has 8 protons. Neutron number is also 8. Okay, we can also represent oxygen 16 by writing out oxygen dash with a 16. And of course, this number here represents the mass number. Do you remember what the mass number again represents? That's right, the total number of protons and neutrons added together. Alright, what's another isotope of oxygen? Well, oxygen 15. Atomic number of 8 because it is oxygen. 15 is the mass number. And we can write it out as oxygen dash 15, which would have 8 protons and 7 neutrons. Alright, so there's some other ways to represent isotopes. So put those in your numbers there. Alright, let's go down to this next question. What are valence electrons? Valence electrons are basically electrons that are found in the outermost energy level or shell of an atom. So electrons found in the outermost or shell of an atom. Alright, so that's the definition of valence electrons. Make sure you know it. Alright, there is a way to predict the number of valence electrons in an atom. We're going to talk about this in class, so for now just skip it and we'll come back to it and discuss how we can use the periodic table to determine the valence electron number for all atoms. Okay, so let's jump down to ions. And this is where we're going to end our class discussion, or lecture 3 is on ions today. So what is an ion? An ion is essentially a charged atom. Alright? The way we represent a charged atom is by showing the element symbol, like sodium, and up in the upper right hand corner we put the charge, like for sodium it would be +1. For oxygen it might be -2. Now what does it mean to be charged? Well, it's simply that you do not have the same number of electrons and protons. In a neutral atom, the number of electrons and the number of protons are the same. But if electrons are lost or gained, then we have an uneven number of electrons and protons. So for sodium, for instance, if you just look at the atom sodium, sodium has, if you look at the atomic number, it will have 11 protons, but because it's neutral, it will also have 11 electrons. However, if you lose one electron, so we lose one, we will have 10 electrons. Okay, so if you subtract the two, you will find that there are one additional proton, or a +1 charge. And so sodium ions would be +1. Okay. Now, if you look at oxygen, on the other hand, oxygen has 8 protons and it has 8 electrons in a neutral atom. But what if you gain +2 electrons? That would give us 2 additional negative charges, or a total of -10 electrons. So -10 plus 8 is going to give you -2 charge, okay, on the ion. So in class we'll probably talk a little bit more about ions and how we form ions by either the addition of electrons or loss of electrons. So in your notes, just make sure you make note of what an ion is, that it is a charged atom, and that it becomes charged by either gaining electrons, and it becomes negatively charged when it gains electrons, or it becomes positively charged if it loses electrons. Okay, so now we're going to talk about the difference between cations and anions. Cations are positively charged ions, and anions are negatively charged ions. So in the case above us, sodium would be considered a cation because it's positively charged, and oxygen is considered an anion because it's negatively charged. One way to remember that cations are positively charged is because it has the word cat in it, and cats have paws. So therefore, cations are positively charged. Anions, they have the word an for like anti or negative. So anions are negatively charged atoms. Alright. So that's pretty much it for our lecture today. Please go back and review this if you need to. We will spend a little bit more time on some details in this lecture, such as looking at ions, how ions are formed, give you some examples in class and more, but at least get a somewhat of an idea of the difference between a cation and anion, define what an ion is, and you should be really good. Make sure you look over isotopes again, what an isotope is, how do we tell the differences between different atoms based on the number of neutrons, and make sure you understand how we symbolize isotopes in atoms. Also look over the basic structure of atoms, the anatomy of an atom, be able to label the different parts of an atom, and you should be really good for the quiz. Okay, that is all for now.